We are back. My name is Seth Juarez, and joining me is Jordan Edwards to talk about ML Ops. We are BFFs.
Yes.
Because people don't know this, but on my day job, I am a cloud advocate when it comes to AI, and so I am the bee in his bonnet.
You make sure all our stuff actually works. So.
Well, I go in there and I'm like, okay, let me see. And it turns out that you all have been releasing so many things so fast that even I haven't caught up. And so now we're going to catch up today.
Perfect. Happy to help.
So for people that don't know what ML Ops is, why don't you describe it to people?
Sure. So ML Ops is how you bring your production ML workloads to the world. So it's how you go from data scientists working locally on a Jupyter notebook to I've got this training pipeline running in production. I've got models flowing through the same release management process as the rest of my other assets that I would want to use. And I've got my data engineers who are happy because they know what data is being used to train these models in the first place, and they can collect information about those models as they're running and know, when they can cook new data to feed back to the data scientists.
So let's talk about this, because you went really fast, and there were so many concepts in there.
Let's run through them,
So generally, when we get started with a machine learning problem, we have a question and we have some data.
Right.
And then we build a thing.
Right.
So let's talk about making that a repeatable process and how we do that using Azure Machine Learning.
Sure. So it's all about the three fundamental assets of any CI/CD pipeline, which is the code, the config, and the data. So as far as the code goes in Azure Machine Learning, whether you're working from a Git repository or locally, we keep a snapshot of all the code that you're doing as you're submitting jobs, whether those jobs are running locally or you're submitting them to go and run in the cloud. When it comes to data, so we have a data sets concept in Azure Machine Learning where we track information about how to access your data, metadata about the profile of your data, and make it easier for you to access as you're running your jobs interactively or as part of a scheduled pipeline.
And this is different. This is just, I'm breaking the set here, everybody. Got so excited.
Dangerous, yeah.
So this is different than regular programming, because regular programming, you're managing the code asset.
Right.
But with machine learning, you have the code asset and the data asset as well, which is what you were talking about with the data set.
Right. So you've got code version management, data version management, and of course, model version management as well, which is sort of the combination of the two of those.
I see.
After you've run a training job on them. Yeah.
So for those that don't know what a machine learning model is, would you explain that?
So a machine learning model is think of it kind of like a binary or a weighted graph or some serialized representation of logic to predict stuff.
I see.
So it's this portable thing that you can pass around from a data scientist who trains a machine learning model to now you can plug it into your data pipeline, whether it's a SQL pipeline or a Spark pipeline, or you can deploy it as an API. So somebody can come and consume it from, say, an application on their phone or an application running as part of a web service.
So I'm hearing it's basically like compiled data into an algorithm that's in a different format that then we use somewhere else.
Correct. It's compiling a predictive graph into a portable format that you can use to make predictions somewhere else. And that graph is tuned based on the data that you feed into it.
I see.
Yeah.
So now that we know that this is an actual artifact,
right,
and the input is the data and the actual code, what do we do about opsing for that model? Because it feels like we need to do stuff with that model, because you might make different ones with different data and different code.
Right. So when it comes to, it depends on how you train the model. For certain well-known machine learning frameworks like scikit-learn and TensorFlow and Onyx, we know enough about the model by you telling us the framework and version that you trained it with, that we have a corresponding pre-built environment we know the model is going to work well inside of. In the case where you have a custom model, you actually can define your own environment that you want it to run in. Typically what will happen is the data scientist will say, this is the environment I trained the model in, and that's kind of like your Python package dependencies, Conda dependencies, your Docker base image, and we'll share that environment from the training side to the prediction side.
So that's interesting. But what do we do with the models? Like, how do we know, like, this is the problem, because look, data science, we're like in the 90s coders, right? We email Python files to each other and model files, which is, we shouldn't do that.
They're big.
They're big, and even if they aren't big, we shouldn't do that. Do we do something with the models themselves?
Right. So in terms of things that we track, so we track snapshots of the code. We track your data sets, we track the environments you're training the models in, and we track the models themselves in model registry.
I see.
And think of that as similar to like a NuGet package feed that you'd have for normal software applications, but it's designed to track and store models.
I see.
Yeah.
And so once I have this version data sets, once I have this version code, then I can produce this versioned model.
Correct.
And now we're getting into like modern ops, right?
We're getting closer, yeah.
Okay,
yeah.
And so once we build this model, there's this notion of environments that tells us how we can run this model. Is
Correct.
that right? Okay.
Yeah.
And in the model, in the environment, is the model part of it?
So no.
Okay.
So the way it works is think of the environment as like it's the shell that you put the model into.
I see.
But you can add different types of models into the environment to make different types of predictions.
Oh, I see. So you can have multiple environments that multiple models may or may not work in, and you can version those as well.
Correct.
Okay.
So say you're training a model to do like energy demand prediction for a building.
Okay.
So I can create the same environment and reuse it with a different model for every building or a different model for every floor of the building. But it saves me from having to recreate the base image for those dependencies like over and over again.
And this is the part that came out super fast that I did not get to look at. So I'm going to ask you a couple more questions about environments. Because usually what happens is when you have a model, you have a scoring file, and that file says how to load the model and how to actually run it.
Right.
So there's two functions, init and run. Does that file form part of the environment, or is it separate from the environment?
So both depends.
It depends.
For the well-known model types, so when it comes to TensorFlow or ONNX or scikit-learn, if you use what we call no-code deployment, the pre-built environment actually already has that score.py with the init and the run inside of it.
Got it.
And it knows how to load like the pickle file or the TensorFlow save model or the ONNX file automatically. Now, in the case of custom environments or custom models, you still need to author that init and run function. However, we've tweaked that a bit so that now you can just use an environment variable to load the model and not need to actually specify the explicit model name. So it means that score.py file is now reusable across different models in your system.
And that was the next question I was going to ask, and you kind of pre-answered that, is that you might create an environment, a custom environment with a special run file, but that special run or scoring file will work with multiple different kinds of models that you build custom.
Exactly.
Okay. So now I'm getting that. So now once we have an environment that we've gone from, we have the code, we have the data, we build the model. In the model, we also with the model we can also build environments.
Yep.
And with those environments, now comes the next question, because those are all useless unless we can put it somewhere for production.
Right.
So tell us about that.
So next up, there's two paths. You can take the model and deploy it to container instances or to Azure Kubernetes Service. And in that case, what we actually do is we take the base environment, we deploy it, and then we mount the model inside of that container and then initialize it. So what that means is you don't copy your model into your container registry. You don't have copies of your model sitting all over the place. They're only mounted on demand when we boot up the service.
And can you mount them by version too?
So it's that you specify the specific model name and version that you want to mount, and that's what gets loaded by the init function, whether it's one you provide or one that's predefined in our pre-built environment.
I see. And so it seems like as we go forward, we're flowing all the versions and things through.
Exactly. It's we're trying to get to the flow where we have the ability to do code, data, and config deployments independently, and this is separating your model deployment from deploying your base environment.
I see. So when we deploy, we're basically deploying an environment married with a model.
Correct.
I see.
Yeah.
And where is that going?
So
you said ACI, but is the ACI part of Azure Machine Learning?
So these compute targets are attached to the workspace. So the Azure Machine Learning will create a container instance for you, or in the case where you're targeting Azure Kubernetes Service, it targets the namespace that you specify and loads the model up inside of there.
I see, and that Kubernetes is something that forms part of Azure Machine Learning.
Correct. We'll create one for you, or you can attach your own existing Kubernetes cluster.
I see. Yeah. Okay. So now we have about 5 or 6 minutes left, because I feel like this is all happening inside of the context of Azure Machine Learning.
Right.
But there's some devs, right, and we call them ML engineers, right?
Oh, yeah.
The ML engineers that use these artifacts, but they're used to a different environment.
Right.
Can you help us understand how we can leverage that environment as well?
Absolutely. So, one of the big things we know from working with customers both inside and outside of Microsoft is that the go-to tool for release management is Azure DevOps. So we actually built native integration to go from Azure Machine Learning artifacts into DevOps. So right now we have a model registered event trigger and a model artifact that you can plumb directly into your release pipeline.
I see, and so walk me through that, because there's two things, right? Because a lot of people do stuff when code is submitted, right? And then something happens in Azure DevOps. Right now you're talking about releasing the model parts. And so tell me more about, so is there an event that gets triggered? Explain how this would work, for someone to set.
Yeah, so the way it works is your data scientist builds and publishes their training pipeline. When the training pipeline finishes, that goes and registers a new model in the system. And that event that a model is registered will go and kick off the Azure DevOps release pipeline to run.
I see. And so there's an event inside of Azure DevOps, release management.
Yes.
That you can, because I know, like you can add the, when code is checked in, or when an artifact is generated, this artifact would be a new model.
Right. Same as connecting to like a package feed to say when a new version of a package is available. When a new model package is available, you can kick off the release, and you can use that artifact inside of the release to say, I want to deploy this thing.
I see. And can you deploy back to the Kubernetes thing? Can you take that model and deploy to somewhere else if you wanted to?
Oh, absolutely. So I mentioned the built-in deployment. We also support the ability for you to take the model and package it. And so you can package it as, just give me a container image that actually has the model inside of it that I could then go and run on something like Azure App Service, or we'll generate also for you a package that can run in Azure Functions. So
I see.
We'll generate a functions package, and that can run as on time or data-based triggers.
And this is the new thing that I didn't get to look at.
Yes.
So tell me more about these packages.
So when you're going and authoring it, you just say what's the target. It's kind of the same as the old image creation flow.
I see.
Except the difference is now we use the built-in environments in Azure ML to package it for you faster. So we have caching on it. And it's more flexible in terms of, we'll also just give you the Docker file and the assets if you want to go and build it yourself. Because some enterprises want to run it through their own secure build pipeline and not use the one that we have.
So basically, you can get a Docker file of the actual service.
Correct.
And you can do whatever you want after.
Exactly, yeah.
And that's the thing, most people don't realize, and maybe you can speak to this, when it comes to Azure Machine Learning, we've made it like a buffet.
Yes.
Not a 7-course meal.
Right.
Why don't you describe how that works?
Yeah, so we have all these capabilities, but you can use them independently of one another. So if you just want to use us for managing models and deploying models, that's fine. If you just want to use us for training and then take the model and run it on your own system or bake it into your own on-prem application, also totally fine. If you want to use us for nothing but doing batch processing of data with these models that you have registered, that's cool too. And so our goal is to be as flexible as possible, have well-documented REST APIs, be super flexible on how you can create and manage things with an infra as code approach, and then also integrate with other systems. So I mentioned we have the built-in DevOps integration. We have integration with Azure Data Factory now as well. But one of the things we just shipped is integration with Azure Event Grid. So the goal is all these event types will flow into Event Grid. You can have them hit a webhook, go into an Event Hub, or wire up a logic app to say, send you an email or create a work item in DevOps. Want to make it as flexible as possible.
I see.
Yeah.
So there was an interesting thing that I got a glimpse of that maybe you can give me a sense for.
Yeah.
There is this problem in machine learning where your data starts to drift.
Yes.
And all of a sudden, the models that you have in production that worked really well last month start to be really stinky.
Right.
Is there a way to operationalize that?
Yes.
Okay.
So the way it works is you have a model that's deployed and running, whether it's in real time or batch, doesn't matter. From the data coming into the model, you just turn that into an Azure ML data set, and then you can create and manage a drift job that runs that compares two data sets. So that can either compare your training data versus the scoring data, or your scoring data over time. Mm-hmm. And so that monitor job runs as part of an Azure ML pipeline as well. And you can set, it'll give you a nice dashboard so you can go and compare how your features are changing over time. But you can also set thresholds to when your coefficient goes above a certain level. Then I want to actually fire off an alert. And that alert will send an email to somebody, but it's also integrated in with Event Grid. So to complete the circle and go back to actually doing automated retraining, you can wire up your training pipeline to run whenever there's new data. You can wire up your deployment pipeline when there's a new model, and you just wire up your drift job to check your data as it's coming in, and that can kick your retraining pipeline. So you can actually complete the circle.
So it's basically, like, this is exciting, because this is the part, this is the new stuff that I didn't get to look at. It's basically, you can just leave it alone.
Yes.
And it will make itself smarter over time.
It will improve over time. Yeah, it's super cool when it's all working together. Yeah.
Well, this is amazing stuff. I mean, I'm really excited. I have to go update all my demos, everybody. So just
I'll help.
But I'm excited for it because the environment stuff, the data drift stuff, to me is super interesting, and it will allow us to do better machine learning. All right, thank you so much.
Of course. Thanks, Seth.
And with that, it's back out into the wild with community reporter Jeffrey Palermo. Jeffrey, what do you got to say, buddy?